So let's talk about a huge challenge. Imagine you have a high-end 4K monitor, but your computer is like over 100 feet away.
Right. A standard cable won't even come close. You'll get nothing.
Exactly. So today, we're doing a deep dive into how you solve that. We've got the technical specs for the NTI ST-C6DP4K-131 Extender.
It's a really interesting piece of kit.
Our mission is to figure out how this thing uses HDBase-T technology to just completely bypass the normal rules and push uncompressed 4K video down a single Ethernet cable.
It's a fascinating case study in, fighting physics. A normal DisplayPort cable just gives up after a few meters.
Physics really is the enemy here. I mean, you're pushing 9 gigabits of data a second down a copper wire.
And resistance just eats that signal alive over distance.
Which is why this NTI device isn't just some passive adapter, right? You can't just splice the ends together.
No, not at all. That's the key. This system has two parts. A local unit, which is the transmitter, and a remote unit, the receiver.
And the magic is what happens between them.
Precisely. It's the HDBase-T technology. Think of it less like a computer network and more like a direct tunnel. It uses the copper wires and the Ethernet cable.
But it's not sending data packets like the internet.
Exactly. No packets, no compression, no lag. It just creates this dedicated, uncompressed video lane. It sort of hijacks the physical cable for its own purpose.
A private highway for your video signal? I like that.
Yeah.
But even on a private highway, the road itself has limits. The specs here have a whole chart, this distance versus quality thing.
And this is where it gets really specific. If you want that headline feature, the 4K resolution at 30 Hz, you absolutely have to use solid KT-SEXA or SIT7 cable.
And that gets you how far?
That gets you the maximum, 131 feet, 40 meters.
Okay, so what happens if you, just grab that old box of CT5E you have lying around?
Your range immediately drops. For 4K, you're down to 115 feet.
Wow.
That lower grade copper just can't maintain the signal integrity for that last 16 feet.
And 16 feet could be the difference between reaching the conference room projector and not.
Absolutely. But the math changes completely if you don't actually need 4K.
Right. What if you're just running, say, 1080p?
At 1080p 60 Hz, the bandwidth needs are way lower. So that same Cat6A or Cat7 cable can suddenly push the signal a massive 230 feet.
That's almost double the distance.
And even on the cheaper CAT5E, you're still getting close to 200 feet. That's a huge difference.
It really shows that trade-off. But let's talk about the image quality itself. Getting a signal there is one thing, but if it's a mess, the specs highlight 4.4.4 color sampling. What does that actually mean for the person watching?
That's a huge deal for anything professional. 4.4.4 means zero color compression.
No subsampling.
Right. Most streaming video, it throws away some color information to save bandwidth. It's why tiny text on a screen can get blurry or have weird color edges.
Fine for a movie, but a disaster if you're a radiologist looking at an X-ray or an engineer looking at a CAD file.
Exactly. This device keeps all of that detail. It's
Yeah.
fully DisplayPort 1.2a compliant.
Here.
That 4.4.4 support is it's non-negotiable for those kinds of professional setups.
And you'd think hardware that can do all that would be pretty bulky, but looking at the pictures, these things are tiny.
They're really compact, about 3.6 by 2.7 inches. They're basically designed to be mounted behind a monitor or under a desk and just forgotten.
And they still handle all the important stuff, like HDCP for hockey-protected content. I did notice the power draw is a little different. The remote unit pulls 8 watts, the local only 5.
Well, that makes sense. The remote end has to do the heavy lifting of perfectly reconstructing that uncompressed signal. It's pretty efficient, all things considered.
So for about $395, it solves a very specific and usually very expensive problem.
It means you don't have to rip open walls to run some specialized, fragile, and very expensive video cable.
You just use the cheap Ethernet that's probably already there. But, looking at these hard limits, 131 feet for 4K, it really makes you wonder about what's next.
It does. It feels like we are right at the physical edge of what copper can do.
If this is the max for 4K, 8K is going to be, what, half that distance? If we're lucky.
We're hitting a wall, a fundamental limit. This device is a brilliant solution for right now, but it also kind of signals the end of an era for copper in high-end video.
So we might be looking at a future where fiber optics aren't just a high-end option. They might be the only option.
I think it's inevitable. The demand for bandwidth is just growing too fast for copper to keep up.
Something to think about before you run your next cable. Thanks for joining us on this deep dive.